Hey, so this is going to be the question that is asked, and it's relatively simple, but there's a lot of moving parts, so let's try to tackle it head on. Um, Water is leaking out of an inverted conical tank at a rate of 0.009 meters cubed per minute. At the same time, water is being pumped into the tank at a constant rate. The tank has a height of 9 meters, and the diameter at the top is 3.5 meters. If the water level is rising at a rate of 0.29 meters per minute, when the height of the water is 3 meters, find the rate at which water is being pumped into the tank. Okay, so first, what it wants us to find is simply at this height, 3 meters, what is the rate at which water is being pumped into the tank? Okay, so let's first find what it tells us. So it first tells us what the d out dt is, the rate at which it is flowing out, which is 0.009 meters cubed per minute. It also gives us the height of the tank, and it gives us the diameter of the top of the tank. But we don't want the diameter. That will come into play later on, but we don't want the diameter. We want the radius. So we'll divide that by 2 to get 1.75 meters. And then the height at which we're analyzing it is 3 meters. So, because it's a conical tank, it's going to be, the volume of this is going to be 1/3 pi r squared times h. And now we'll inevitably have to find the derivative of this thing right here, because we need to find the rate of something. But if we took the derivative of this right now, this r variable right here, that would create some problems, because we would have to do the product rule, and it'd be a lot of work. So I'll show you how to do it a little bit faster than that method. So what we'll want to do is get rid of this r variable and replace it in terms of h. And how we'll do that is we'll use the rule of similar triangles. So this is the inverted tank. So if we have a height right here, let's say little h, and a radius right here of little r, and the height up here is big H, and the radius is big R. So because they share the same angle right here, that means they're similar triangles, meaning the relationship between their radiuses and their height are going to be the same. So we'll simply relate that. I think I actually wrote this one down. So we'll simply relate that through this equation right here. So H being our 3, R being the relationship we need to find, and the height of T being 9, and the R of T being 1.75 meters. So after we switch these variables around, we inevitably get up getting 9, or R equals 7H divided by 36. And then we can simply replace this value for R in right here. So now it reads V equals 1/3 pi times 7/36 times h squared times h. Out, we get this equation right here. And then we can find the derivative of this with respect to t, which ends up getting right here. So we have our h value and we have our dh dt value, but we don't have a dv dt value. But we do have a do dt value. And what dv dt value is the rate of change, the total rate of change of the volume in this tank, which is just going to be the input minus the output. And we can change that to look like this. And if you look at it, we're trying to find this di dt. And we have do dt, we have our h, we have our dh dt. So we replace those values with what we know it is, and then we solve for di dt, and we get our answer, which is di dt equals 0.319 meters cubed per minute. All right, that was a little bit fast. I feel like I was talking like an auctioneer for a minute, but hopefully that was helpful. All right, thank you very much.